Hello, Haripriya.
Um, Hi, sir. Sir, if you complete waves, please complete physical.
If I complete waves, then it will be completed, na? Physics.
Yes, sir, I'm asking you.
Hmm. Then it will be completed. So now the waves part, na? See, the waves actually consist of two. Waves are of two types. One is transverse wave, and the other is longitudinal wave. Haripriya, when is your exam? Physics exam?
Sir, physics, it's 18th.
It's on 18th, na? Okay. Okay, I'll try to complete it fast. So we'll start from the
I
trans.
have my maths on 14th.
Maths is completed. Everything is done.
Yes, sir.
Hmm. We'll try to complete fast. See, transverse waves. Transverse waves are those types of waves in which the motion of the wave is like this. Like this. Means in which, why we say it is transverse? Because the motion of the particle takes place perpendicular to the x-axis in the y direction. Up, down, up, down, up, down. And the wave motion is like this. That's why they are known as transverse waves. But the important thing is for solving problems, what you need to know, there are few important terms related to it that are that let me tell you first. First, this is wave. The distance between the two similar points is known as wavelength. You know this one, no? This is wavelength. And if this is displacement x, this is supposed to be y. And wavelength is there. And this, if you take this point A and again this point B, This after this the wave gets repeated from A to B. It represents a complete cycle. Okay, that's one thing. Now, before starting transverse wave, there is an important condition that it should satisfy. Every wave should satisfy d square y by dx dt square is equal to v square into d square y by dx square, where v square is what? V is the wave velocity. What is wave velocity? Wave velocity is the velocity with which this wave is moving forward. There are other terms also that I'll discuss. But why I have given this type of equation to you? Because in JEE Main examination, not in CBSE, in JEE Main examination, they will ask a random equation, and then they will give you a random equation, and then they will ask you to show whether which of the option is which one of the option represents the wave equation, transverse wave equation. Then if any of the equation satisfies this one, then that is a wave equation. So the standard equation for a transverse wave is y is equal to a sine kx minus omega t. What is A? A is the maximum displacement or amplitude, up and down. Okay. Now, this part is known as the upper part is known as the crest, and the lower part is known as trough. Everywhere. This is crest, then trough, like that. What is K? K is known as wave number. It's represented by 2 pi by lambda. Omega is the angular frequency. In radian per second, it is 2 pi by t. Omega is 2 pi by t, where t is the time period. What is time period? Time taken to complete one cycle. Okay. These are the few formulas that are actually very important, because on the basis of this only you will be solving the questions will be asked in JEE Main and as well as in your CBSE. Sometimes they give one more type of frequency, that is F frequency is 1 by t, 1 by time period. Its unit is hertz. How you will identify which frequency they are talking about? If the unit of the given frequency is in hertz, it's 1 by time period. If it is given in radian per second, then it is 2 pi by t. Okay. Okay. Till here, everything okay now? Now, the part inside this sine, this kx minus omega t, is known as phase. Phase of a wave. Okay. Now, what they say the phase of a wave is always a constant value. It does not change. The value remains constant. Now, if x is the displacement, means x is the position of a point in a wave from the original point, then what you can do is you can just differentiate this thing. If we differentiate it, it will become k dx by dt minus omega is equal to 0. Because phase is constant, you will differentiate it, you will get the 0 value. So this dx by dt will become equal to omega by k, And what this dx by dt represents, look carefully. This dx by dt will represent the velocity of the wave, v. So from this we get velocity of a wave is omega by k, where omega is angular frequency, k is the wave number, 2 pi by lambda. Clear? Haripriya okay na? Kanishka okay?
Yeah.
Okay. Achha, do you remember about simple harmonic motion? In simple harmonic motion, the particle was moving up and down, to and fro, like this. Hmm? There also, do you know, remember this, the particle's displacement was given as A sine kx minus omega t.
Yes, yes.
Or I think they have given omega t minus kx. Actually, I've represented like this. It's actually they write it like this: omega t minus kx.
Omega t minus kx, and this is like
Hmm.
omega t minus this sign. I mean the minus pi.
Hmm. Not a problem. You can write any way. Both are same. Both are same. Only the direction of motion is different. Now omega t minus kx they write in the simple harmonic motion. What it represents, a to and fro motion. Now when it is given like this, means the particle is moving up and down in the wave. So the particle velocity is given, particle displacement is given by y. Particle velocity, if I talk about, it's dy by dt. You must be knowing it is a omega cos omega t minus kx. Na? You remember all those things. V particle is this a omega cos of omega t minus kx. And when we talk about V max, it will be plus or minus a omega. When cos omega t becomes 1 plus 1 and minus 1 at the origin. Those rules of this one, no, they apply here. Those rules of simple harmonic motion applies here. Remember those things? Wave velocity is different than the particle velocity. Wave velocity is the velocity with which the wave is moving forward. That's v here. Particle velocity is the particle with which the velocity with which the particle is moving up and down in a wave. See, when wave will travel, na, particle is here only. Wave will travel when, suppose think like this. When the wave moves, the particle comes here. When this backward parts comes to this position, the particle will move up. Then it will move to top position. Then the behind part will come here. So it will this position, the particle position will move down. Then if this A position comes here, the part of the wave which comes to this position, the particle will move down at the zero position, y is equal to zero position. So like this, particle will be moving up and down. That I am talking about. And the particle velocity become maximum when it is at y is equal to 0, moving up and down. Why I'm saying this now, I'm going to give you one question, very quick question. Try to solve this. Let me give you one more question.
Sir, option
Option
B, pi y naught.
correct. Kanishka, you got the answer or you want me to do it? This is this. This represents your omega and this represents your 2 pi by lambda is equal to k. So the particle velocity, maximum particle velocity will be what? Omega V max particle is 2 pi f y naught. And what is wave velocity? Omega by k, na? 2 pi f by 2 pi by lambda, f into lambda. What they have given? 4 times the wave velocity. V max p is 4 times the wave velocity. So 2 pi f y naught is equal to 4 into f lambda. The lambda value they are asking, no? This will cancel. This will cancel. Lambda is equal to pi y naught by 2. Option B. Now try to solve this quickly. This one.
Eruption D16.
16, wait. Correct. Frequency is 1 by time period. It's 3600 by 60 hertz. V is equal to omega by k. V is 960, so it is 2 pi by t, 2 pi by lambda. Okay, now let me tell you, this was the basic part. Now let me start the actual thing from which your transverse wave actually starts. This was the basic part. Questions are asked on this, but this part is important. From this part, actually the things start in waves. The transverse wave velocity that we have calculated omega by k, that is actually calculated in a different way in a string having tension. Means what we do, suppose we have a string here, and it's in tension. Means we have applied a force here, which is due to which the tension T is present everywhere in the string. Now we have given a small disturbance at one end so that a wave is formed. Now they say that the velocity of this wave v is equal to root over t by mu. Derivation is actually not needed at this point. If you want, I can tell you, but derivation is not at all needed. It's small derivation only, I can tell. T is the tension. Let me do the derivation, it's very small. Mu is the mass per unit length. Of the string material. Okay, if the mass of the string is m, the length is l, then you can write this value mu as m by l. How do we derive it? We take the small portion here, assume there is a center for this. It's making an angle of theta and 1/2, so the total angle is 2 theta. Theta here, theta here. Suppose the tension, because the tension is equal everywhere it is transmitted, this is also theta, this will also be theta. Let's say it is 90 degree, this is 90 minus theta, this will be theta. So Here the force on this in this direction will be t cos theta. Here also it will be t cos theta. The force downwards will be acting as t sin theta due to this part, and again t sin theta due to this part. But it is doing the circular motion. So I can write 2t sin theta is equal to mv square by r, the radius. I'll keep theta very small, so it will be 2t into theta is equal to mv square by r. T is equal to mv square by r into 2 theta. If you know about arcs, if it is making an angle of theta here, radius is r, so we know L is equal to r theta in an arc. This you know na, Haripriya?
Yeah.
So T will be equal to mv square by r into 2 theta is L, the length we have taken. So m by L is mu, so I can easily write T is equal to mu into v square, so v will be equal to root over T by mu. This is how we derive this. But it's not needed. Actually, they won't ask you. Derivation won't be asked. The important thing is that you know this formula whenever there is a string with tension and we have created a disturbance at one end and a transverse wave is traveling, then the velocity of that particular velocity of the transverse wave, the horizontal velocity of the transverse wave is given by root over T by mu, where T is a tension unit and mu is the mass per unit length. Let me give you one question on this. The first tell me you are able to understand the question or not. Haripriya, do you understand this question?
Yes.
Okay. Diagram is something like this. What they are saying na, it's something like this. It is 12-meter long. Mass is 0.9 kg. There is a thread attached to it. Cord attached to the end passes over a pulley and supports an object with a mass of 5 kg. This is a mass of 5 kg. The tube is struck transverse flow at one end. Find the time required for pulse to reach the other end. Means what they have done now, they have struck it at this point. What is the time taken for the pulse to reach this end? The other end they are asking. Question is good. Actually in physics they should form these kinds of questions only. Direct questions are not interesting.
Then I'm getting 0.47 seconds.
Yes, you are getting correct answer. It's not wrong. It's actually not difficult. It's simple only. Where here, what you have to do because the system is in equilibrium, na. the velocity, velocity of the transverse wave which will be produced at one end if it is struck. The velocity will be root over t by mu. Mu, you can calculate its mass per unit length. 0.9 divided by length of the tube, 12 meter. 3 by 40. This But tension we have to find. To find out tension, we'll have to make the free body diagram. Free body diagram we can make T is equal to 5g it is. So tension will be 5g. So velocity we can find it is the root over 550 divided by 3 by 40. 5 into 4 into 100 divided by 3. 10 root 20 by 3. This is velocity. So velocity, the time required, they're asking the wave pulse is moving from A to this point B. So velocity is equal to this distance by time. The time will be equal to AB, which is 12 meter, divided by this velocity, 10 root over 20 by 3. So 3 by 20. If you calculate this, you should get the answer. 12 by 10 root 3 by 20, it is 0.47 seconds, right? This only you have done now?
Yes.
Now see, on transverse wave, when they ask question, the questions will be of this form only. Now let me teach you about the longitudinal wave. Few basics only I'll tell. Then after that the equations and all I'll tell you later. What is longitudinal wave? First you should understand what is longitudinal wave. Like this transverse wave move in crust and trough, na? Longitudinal wave, actually in the longitudinal wave the motion of the particle is horizontal. It moves to and fro, SHM motion is there, but the particle motion will be front and back. In the transverse wave, it was the motion of the particle was perpendicular to the direction of motion of the wave. Yes. So what happens here? There are places where the density becomes high, and there are places where density becomes very low. Like this. This portion will be low density. This portion will be high density. Understanding? And this is happening because the particles are moving forward and backward. And they are nothing is new. There is a name for it. This is known as compression. And this portion is known as rarefaction. But this much detail is not needed for you. This is only the basic thing, basic of the longitudinal wave velocity. See, because the SHM this SHM is there. Since SHM of the particle is there, the equation of this, if we talk about the equation will also be of this type only. Vy is equal to a sine kx minus omega t, like that. Okay, but the formula wise, when they'll ask you in JEE main or in your board examination, class 11 board examination. So there few formulas will be helpful for you. The velocity of longitudinal wave in solids, it's given by v is equal to root over y by rho. You know na, this Young modulus and all. This y is a Young modulus. Young's modulus. Rho is density. Density of the wave. And in the gas, it will be v is equal to root over b by rho. B is bulk modulus. Also in the gas, there is one more formula, that is P by rho, but this was actually later corrected. P is the pressure. It was later corrected and there was a Laplace correction, root over gamma P by rho. This is the actual formula that is being used. Gamma is the ratio of specific heat capacity. Because you know PV is equal to nRT is also there. Gas laws. So, and N is M by capital M. So you can write this equation also as Pm is equal to M by V. Mass by volume is density, rho RT. So P by rho will be equal to RT by M. So you can also write this formula as root over gamma RT by M. This is also a famous formula, but what you have to remember now, these two formulas, either this formula, this formula and this formula is actually very widely used. They use it so many times. But these three formulas, this root over b by rho and this gamma p by rho or gamma RT by rho, these formulas are used for gases, finding out the velocity of longitudinal wave in gases, and the above formula is used for finding out the velocity of longitudinal wave in solids. Okay. Now actually, Haripriya, tell me one thing. In your school, did they teach you about the superposition of waves, in which the maximum amplitude and minimum amplitude they have calculated?
Yes, yes.
Okay, because it's taught two times. It is taught two times. When you will come in class 12th, na, there in the wave optics also you will be taught the superposition of waves. If they have taught you, then you'll have to study. Okay. Acha, few formulas also I'll give you now. Then after, in the next class, probably we'll start that one, superposition of waves and all. These formulas are related to the transverse wave. First formula is of energy density. It's energy per unit volume. Do you remember what's the energy of a particle doing SHM? Total energy of a particle doing SHM. Hey Priya, do you remember the total energy?
Yes, sir. Half omega square A square.
Half m omega square a square. If we divide it by volume, half m by v into omega square a square. Mass by volume is density, so half rho omega square a square. That's the formula. This formula you should remember. So energy density is half rho omega square a square. Now coming to the next formula, that is power. Power is what? It's actually work per unit time, but work is also a form of energy. So we can write like energy per unit time. So energy is half m, or we can write like this, half rho omega square a square into the volume divided by time. Volume, I'll write area into this. So half rho omega square a square into area into x divided by time. So x by t will be velocity. So half rho omega square a square s v. That's power. See, these are actually, you may be thinking why we are studying these formulas, but they are very, very, very small formulas, and direct application of these formulas is there. They'll give you a question in JEE when I'll show you the questions. Probably next class I'll show you. Direct questions are there, and on if you know this formula, you will be able to solve it. If you don't know, lost 4 marks. Then the third is intensity. Intensity is energy per unit area per unit time. We know energy is, energy per unit time is already power. So I'll write half rho omega square a square s into v. It's power divided by area. Area we have taken as s. So half rho omega square a square sv divided by s. SS will cancel. So intensity formula will become half rho omega square a square v. Okay, so intensity is actually proportional to square of the amplitude. That's important observation. It will be useful when we'll be doing the next part, no? Superposition of waves. So I'll write the heading superposition of waves, then we'll do it in next class. Okay, let's end it. This part we'll do in the next class. Superposition of waves. Okay, Ripriya. Probably in the next class I'll try to complete this chapter. Two superpositions are there, and then there's the organ tubes. Doppler effect, did I teach you?
Uh, no, no certificate.
Doppler effect is not there in JE syllabus, but it's asked in JE Advance. So I'll teach you later, but not now. Okay, let's end it. Good night. Bye bye.
That's
Bye bye.